of chapter 1 real numbers is prove that root 5 is irrational. So what we have to prove, that we are writing first. To prove root 5 is irrational. On contrary, we suppose that root 5 is rational. Why we are doing this? Because for irrational numbers cannot be expressed in p by q form, whereas rational number we can write rational numbers as p by q form. Okay, so we are supposing that root 5 is rational. So if root 5 is rational, what we can get? Root 5 equal to p by q, where q not equal to 0. But these two numbers, they may have a common factor. So by reducing this to the lowest fraction, we will get root 5 equal to some other alphabets we will take, a by b, where a and b are co-primes. Okay. Now what we have to do? We will square on both sides. We get root 5 whole square is equal to a by b whole square. Square and root get cancelled, and we get here 5 equal to, by laws of indices we get here a square by b square. Now this b square will shift in towards LHS. 5b square equal to a square. This we will assume as the first equation. Okay. Now further, what we do here, what we can say here by seeing this equation, that 5 divides this a square. So I'll write this in statement: 5 divides a square. So by theorem we can say that if 5 divides a square, we get 5 divides a. If 5 divides a, what does it mean? It means that a will be equal to multiple of 5. So 5 into some variable. That is, we will take here c. A equal to 5c. Okay. So we got a equal to 5c. Now we will square on both sides. So we get a square equal to 5c whole square. That means this square applies to both of these when we open the bracket. 5 square into c square. That is, it is equal to 5 square is 25 into c square. Here we got a square equal to 25 c square. But from first equation, what do we have? The value of a square. A square we can write as 5b square equal to 25 c square. Now here we have 5. We will shift this to RHS. So it will become b square equal to 25 by 5 c square. So on cancelling we get 5 ones are 5, 5 5s are 25. That is b square equal to 5 c square. Then what does it mean? 5 divides b square. From theorem what we can say then? 5 divides b. If it divides b square, then it will divide b also. Okay. But what did we get previously? We got 5 divides a. Now we are getting 5 divides b. So what we can say? 5 divides both a and b. But what are a and b, students? They are co-primes. So if a and b are co-primes, can this statement arise? It can't arise. So this contradicts the fact that a and b are co-primes. This contradiction arises due to our false assumption. Hence, we conclude that our assumption is wrong and the given statement is true. That is, root 5 is irrational. Okay, students? Next sum is prove that 1 by root 2 is irrational. So on contrary, we will suppose that 1 by root 2 is rational. That is, it can be written in p by q form. So we can write 1 by root 2 equal to p by q, where p and q are integers and q not equal to 0. Okay. So by reversing this, we get root 2 by 1 equal to q by p. So by observing, we see that RHS is in p by q form, but LHS is root of prime, which is irrational. So in the previous sum, we proved that root of a prime number is irrational. So here we got LHS equal to irrational, RHS equal to rational number. This contradiction arises due to our false assumption. Hence our assumption is false and given statement is true. That is 1 by root 2 is irrational. Okay students? Prove that root p plus root q is irrational where p and q are primes. So it is given that whatever is given, first we will write that. Given that p comma q are primes. So if they are primes, what we can say? We can conclude that root p comma root q are irrational numbers. Since root of our prime number will be irrational, we are writing this. So if these two are irrational, then the sum of the numbers, that is sum of these two irrational numbers, what we will get? Since these both are irrational, if we add these two, what we will get? We will get again a irrational number only. So we have proved that root p plus root q is irrational number using p and q are primes.